Welcome to AskPrep. My name is Gagana. In today's class, we'll study second chapter of class 11, that is structure of atoms. So the word atom was derived from the Greek word atomio, which means uncuttable or non-divisible. So you cannot divide an atom. So this theory was first proposed by John Dalton. So, this John Dalton was able to explain the law of conservation of mass, the law of constant composition, and law of multiple proportions very successfully. But he couldn't give the Avogadro's law and all. He couldn't satisfy with the help of these explanation of atomic theory. Then, what are the subatomic particles present in our atom? Electron, proton, and neutron. These are the subatomic particles present in an atom. So, before we discuss, we need to keep in mind the basic rule of the charged particles. So, as these are the charged particles, electron, proton, and all these are charged. So, like charges repel each other, and unlike charges attract each other. The next concept is discovery of electrons. So, who discovered electron? Basically, electron was discovered by J.J. Thomson. So, before that, coming into the conclusion of discovery of electron, there is a scientist called Michael Faraday. So, he studied the discharge of electricity in partially evacuated tubes known as cathode ray discharge tubes. So, electricity was discharged in these tubes. The electrical discharge is through gases, and the electricity was discharged only through gases at very low temperature and high voltage. So, at very low pressures and even at temperatures, temperature is high voltage, at the high temperatures. So, the pressure of the different gases is adjusted through vacuum pump by their evacuation. So, with the help of the vacuum pump, different gases pressures are adjusted. So, this is the cathode ray discharge tube. So, this is the tube and this is the vacuum pump for different gases to enter and exit. This is the cathode uh, tube and this is the anode. This is the high voltage which is supplied through these electrodes. So cathode ray tube, what it is made up of? It is made up of a glass with two thin pieces of metal called electrodes which are sealed in it. So this is why two electrodes which are sealed in it, they are connected to a high voltage battery, and these are called cathode and anode. So, when sufficient high voltage is applied across the electrodes, current starts flowing through stream of particles moving in the tube from negative electrode to positive electrode. So, in the tube, we had seen that the electron moves from negative, that is cathode, to positive, which is anode, and they are called cathode rays or cathode ray particles. So as the electricity or the current moves from negative to positive, it is called cathode rays. So if the absence of electric or magnetic field also, these cathode ray particles travel in straight line. So this is the cathode ray discharge tube with perforated anode. So anode is induced in that. This is cathode, this is anode, and this is the vacuum pump for the passage of gases. This is the high voltage. This is the fluorescent screen. So fluorescent screen is basically used to check out the particles emitted. This is the perforated anode which helps to filter the particles. This is how the ray passes and it gets deflected, and we can see with the help of the fluorescent screen, based upon the color emitted, we can check out the gases which is obtained or the particles which are receiving from the cathode. The flow of current from cathode to anode can be checked by making a hole in the anode, and behind the anode there is a fluorescent or a phosphorescent material which is called the zinc sulfide. So that material is made of zinc sulfide, and these rays pass through the anode and it strike the zinc sulfide screen. So as a result, a bright spot is developed across that screen, and this principle is applied in the television. So whenever the current is flowing from cathode to anode, it reaches the screen or the zinc sulfide screen, the phosphorescent material, and then that ray passes through the anode and it strikes the zinc sulfide. So as a result, there is a glow of light or any bright spot is observed on the screen. So that is how we watch our televisions. This phenomenon is used. So in the absence of electric and magnetic field, the cathode rays also travel in straight lines. In the presence of the behavior is very similar to negatively charged particles called electrons. So if it electric or magnetic field is present in the passage of this cathode rays, it acts as electrons. They act as a negatively charged particles. So negatively charged particles are called electrons. So then what are the characteristics of cathode rays? So these do not depend upon the material of electrode and the nature of gas present. So whatever the material may be or whatever the nature of the gas which is present in the cathode ray tube, the cathode rays or the electrons do not impact the electrons. And the basic constituents of all atoms are electrons. So, what are the basic constituents of of atoms? Are electrons. Atoms are mainly composed of electrons. Cathode rays come out at right angles to the surface of cathode, and the direction of emission does not depend upon the position of anode. So, they deflect out at right angles the surface of cathode, and their emission, it does not depend on the position of anode. So it does not depend upon the anode position. Wherever the anode is placed, it does not depend upon the how to emit and all. So it emits independently. And these are not formed in the discharge tube, evacuated discharge tube. So they ionize the gases. Ionize the gases in the sense, if the gas is present, it splits. Any gas is present, it converts into ionic form, and indicating they are charged particles. Suppose if you add any helium gas, so that helium gas is converted into He plus ion. So it is a ion, it is ionizing the gas. So it is converting into ion, so that He plus is charged now as it is in ionic. The next concept is charge to mass ratio of electrons. So this was given by J.J. Thomson. So J.J. Thomson measured the ratio of electric charge to the mass of electron by using a cathode ray tube and applying electric and magnetic field which is mutually perpendicular to the path of electrons. So how the electric charge, the mass of the electron is measured with this cathode ray along with the electric and magnetic field which are mutually perpendicular with the traveling path of that electrons. So this is the apparatus which is used to determine the charge or mass to mass ratio of an electron. This is the anode and this is the cathode. This is the magnetic field applied, and the above is this is the fluorescent screen. This is the electric field, which are mutually perpendicular, and when you pass any gas through it, it first hits the anode, then it passes through the electric or the magnetic field. These are the different screens. A, B, C are the different points on the screens where the light deflects or the electrons strike the surface of the screen. So greater the negative charge. So what is the magnitude of the negative charge on the particle? So if the negative charge is more, there is the more interaction with the electric or the magnetic field, and hence the deflection is more. So if the negative charge is more, the electrons get deflected more. So if there are more electrons, what happens? It moves apart, it moves very quickly. So as the voltage increases across the electrode, the strength of the electrodes also increases. As there are many electrons, you supply more voltage, and the deflection is also more. So it moves very fastly. So mass of the particle. Lighter the particle, higher the deflection. So if the particle or the electron is very light, then what happens? It quickly deflects because there is no weight in that. And strength. So if the voltage is high, the strength increases of the particles. When only electric field is applied, electrons deviate and hit the cathode ray tube at point A. So we have already seen this is the point A. So if only electric field is applied, no magnetic field is applied, it reaches the point. So if to balance both electric and magnetic field, so if both are applied simultaneously, that is both electric and magnetic field, they hit the straight line, that is the zinc sulfide screen of the cathode ray tube at point P. So when only magnetic field is applied, the electrons deviate from their path and hit the cathode ray tube at point C. So if only magnetic field is applied, it reaches the point C of the zinc sulfide screen. Only electric field, it is the point A zinc sulfide screen. If both electric and magnetic fields are applied, it hit the screen at point P with the straight line. So by carrying out these measurements or the amount of the deflections by the electrons on both electric and magnetic field, so Thomson gave or he was able to determine the electron or the charge to mass ratio of an electron. Charge by mass is equals to specific charge, that is equal to charge per unit mass. So E by ME value is 1.758820 into 10 power 11 coulombs per kilograms. E is the charge of the electron, that is 1.602 into 10 power minus 90 coulombs. Me is the mass of the electron, that is 9.11 into 10 power minus 31. So, charge to mass ratio of an electron. So, here how to calculate? So, what did Thomson do? He gave the how the electrons behave with the help of he was able to determine the charge to mass ratio of an electron. So, Millikan, with the help of an oil drop experiment, he accepted the value of the electric charge or the charge of the electron. He combined the Thomson's value and he gave an experiment value of oil drop experiment. So, Mulliken oil drop experiment. So, this is the charge plate. This is the negative charge plate. There's a small hole. This is the X-ray which is obtained from the source. This is the oil droplets and this is the atomizer which lets the passage of oil with the help of a droplets. This is the telescope with micrometer eyepiece, so we can record what is happening inside the vessel. So now what happens? See, oil droplets are found in the form of a mist or very small droplets with the help of the atomizer. So this atomizer helps in creating a small drops which is passed through small hole and in the electrical condenser. So these droplets move downward and with the screen with the help of a telescope. So we can see as it is a very small droplets, it is moved. So by measuring the rate of this fall, so the mass can be determined. So at what speed the oil droplets fall into the surface area, the mass can be calculated. So how thicker it is. So if it is thicker, how long it takes to fall from the higher surface. So this is what is calculated. And the air in that chamber of the vessel was ionized by passing a beam of X-ray. So X-ray was passed, X-ray was allowed. So to ionize the air. So air consists of many gases particles. So we need to ionize those air particles So we need some rays. So that is the X-ray. So the electrical charge which is present on the oil droplets, so this is acquired by the collisions. So as the gas molecules start colliding with each other, they use the electrical charge which is obtained by the oil droplets. So by measuring the effect of the electric field strength based upon the movement or the motion of the oil droplets, this Millikan concluded that the magnitude of the electrical charge Q is equals to Ne, that is the integral multiple of the electrical charge. So, the magnitude of the electrical charge is directly proportional to the integral multiple of the electrical charge. Q is equals to Ne, N is the integer, that is 1, 2 and 3. So the what are the forces acting upon these oil droplets then? One is the gravitational force that is falling from upper surface to which is the ground, and the electrostatic force between those molecules, the air molecules or the present in the ionizing molecules, there is some electrostatic force. So that is called the gravitational and the electrostatic force which is acting on the oil droplet. So it can be stationary also, the fall of the uh, oil droplets. So the next concept is about discovery of protons and neutrons. Electrical discharge is carried out in the modified cathode ray tube, which led to the discovery of canal rays carrying positively charged particles. So, then what are the characteristics of these positively charged particles? Unlike cathode rays, mass of positively charged particles, it depends upon the nature of the gas present in the cathode ray tube. So they are simply the positively charged gaseous ions. The charge to mass ratio depends upon the gas. Here, cathode ray do not depend upon the any nature of the gas in the cathode ray tube. But for protons or the positively charged particles, they depend upon the nature of the gas and also the charge to mass ratio of the particles which is obtained from the gas. And some positively charged particles carry a fundamental unit of electrical charge, that is the current or ampere, and this behavior of the particle is which is opposite to that of the magnetic or the electric field which is applied in the cathode rays. So the smallest and the lightest positive ion which was obtained from hydrogen, and it was called proton. So the proton was obtained, or the positively charged particle was obtained from hydrogen. The neutral particle, there was another neutral particle that is called neutron. These neutrons were discovered by Chadwick in the year 1932 by bombarding a thin sheet of beryllium alpha particles. So when he bombarded beryllium, alpha particles was obtained, and these alpha particles are neutrally charged. In the sense, he came to a conclusion that with the help of the positively charged alpha particles, he obtained neutrally charged particles. Then electrically neutral particles are obtained with the help of the which are slightly greater than their mass is slightly greater than that of protons are emitted, and he named these particles as neutrons. So atomic models. So J.J. Thomson, he already discovered the electron. He proposed one atomic model based upon the discovery of electrons. So he proposed an atom possesses a spherical shaped radius approximately which is equal to the 10 power minus 10 meter, in which the positive charge is uniformly distributed. So, he said that a positively charged is uniformly distributed in an atom where electrons are embedded in it with the help of the electrostatic force of attraction. So this is called as plum pudding or raisin pudding or watermelon model. So this model is visualized as how in watermelon the seeds are embedded. So watermelon is a positively charged particle. In that the seeds are the electron which are embedded in it. So the feature of this model is that mass of the atom is assumed to be uniformly distributed over the atom. So the mass is uniformly distributed, and this is the sphere of the positive charge, whereas negative charge particles or the electrons are embedded in it. So then what are the drawbacks of this J.J. Thomson model? So why it couldn't satisfy the basic conditions or of the electron existence? So, based upon this model, it couldn't explain the stability. So, how stable the atom is present inside the positively charged sphere, how the electrons are arranged, so how stable it is, so how long it can survive holding the electron with the positively charged. Because positive and negative, there is some attraction, like charges repel each other, unlike charges attract each other. So there is a force of attraction. So how stable the atom can hold all those electrons and all, it couldn't explain. So the next one is concept is the discovery of X-ray. So how X-rays was discovered? William Röntgen in 1895, he showed that when electrons strike a material in the cathode ray tubes, they produce rays which called fluorescence. With that fluorescence material is placed outside the cathode ray tube and name them as X-rays. So in the cathode ray tube, when in a cathode ray tube, they produce rays with the help of the gas particles, and that causes fluorescence in the fluorescent materials. And that fluorescent material is called X-ray. These X-ray strike the dense metal anode, and these are called the targets. They are not deflected by electric or magnetic field, hence their high penetrating power. So they are not deflected with the help of the magnetic and the electric field. And that is why it is used in the study of the interior of the objects or the our human body itself. And they are very short wavelength rays, and they possess the electromagnetic character. The next concept is discovery of the radioactive elements or the rays. Henry Becquerel, he observed that there are certain elements which emit radiation on their own, and they named this phenomena as radioactivity, and the elements are known as radioactive elements. So this field was developed by Marie Curie, Pierre Curie, Rutherford, and Frederick Soddy. So they observed three kinds of rays, that is alpha rays, beta rays, and gamma rays are emitted on their own. So Rutherford, he further classified alpha rays as high energy particles which are carrying 2 units of positive charge, 4 units of atomic mass. And he also concluded that alpha particles are helium nuclei, whereas alpha particles are combined with 2 electrons yielding helium gas. So, where alpha is positive, beta is negatively charged particles, and the gamma rays are high They are neutrally charged. They are high energy radiations like X rays, and they do not consist of any particles. They are rays, and they pass with they penetrate very deeply in the interior objects. So that is why they are called high ray penetration rays. The order of penetration is alpha is less compared to beta compared to gamma. The next model of an atom is Rutherford's model of an atom. Rutherford and his students, Hans Geiger and Ernst Madden, they bombarded a thin gold foil of thickness of about 100 nanometer with alpha particles. So what they did, they took a gold foil and they bombarded the gold foil with the help of positively charged alpha particles. So a stream of high energy alpha particles were directed at a thin foil of gold metal. So alpha particles of high energy were supplied to thin foil of gold metal. The thin gold foil has a circular fluorescent zinc sulfide screen around it. So around the zinc sulfide screen, a thin gold foil was around the thin gold foil, a zinc sulfide screen was present. So whenever alpha rays strike zinc sulfide screen and it causes glow on the screen. So this is most of the alpha particles pass through the gold foil and deflected. So small particles were deflected by small angles, so 1 and 2000, and they bounced back. So this was the alpha particles. This is the lead plate which helps to filter the particles and it helps to pass through the gold foil. So this is the gold foil and the alpha particles are deflected. This is the zinc sulfide screens which is surrounded. So then what is the conclusion? So most of the atom is empty as most of the alpha particles pass through the gold foil and deflected. A few alpha particles deflected and indicated us a high density of positive charge in the small volume of atom which undergoes repulsion. So what happens when atom is small, it will more positive charge. So as it cannot sustain in that atom, it moves out, it deflects out, indicating small volume. The central part of the atom in which the entire positive charge in the mass is concentrated, this is called nucleus. So this is the center part. There is all the positive charge and the mass of the mass of the atom is concentrated. So the volume occupied by the nucleus is negligible as compared to the total volume of the atom. The radius of the atom is 10 power minus 10 meter. Radius of the nucleus is 10 power minus 15 meter. Alright students, I hope you found the lecture understandable. If you had any questions or doubts, please feel free to comment us or email us. Goodbye students. Ask us anything from AskPrep.